Hey, you amazing knowledge seekers, and welcome back to the deep dive. What if the very matter around us, your coffee cup, the ground beneath your feet, and even a falling apple, actually feels something?
We're really going there, huh?
Before we plunge in today, just a quick heads up. If you really dig getting the universe explained in, bite-sized brilliance, go ahead and hit that like button and definitely subscribe. It honestly fuels our deep diving dreams.
It really does.
All right, so you sent us this really fascinating piece. It's Robert Pepperell's What Matter Feels: Consciousness, Energy, and Physics. How Science Can Explain Minds.
Mm-hmm.
Now, this isn't your typical dusky textbook, is it? It feels more like almost a revolutionary manifesto.
Mm-hmm.
It's proposing this wild new way to see basically everything around us.
Yeah, especially that really tricky connection between our minds and, the physical world.
Totally.
Think of it as a kind of conceptual toolkit Pepperell's building. He's suggesting that matter itself might have these hidden psychological dimensions.
Hidden dimensions. Wow.
And he's not just, idly speculating here. He's actually laying out a framework that could potentially lead to real experiments that might unlock some of the biggest mysteries out there.
Yeah, like what kind of mysteries are we talking?
Well, things like why we feel pleasure and pain, what actually sparked life in the first place, why we find some things beautiful, and the really big one, what exactly is consciousness?
Okay, so get ready, folks, because this sounds like it's going to turn some assumptions completely upside down. We're definitely going to unpack some truly mind-bending stuff today. Ideas like matter having a kind of sensitivity.
Mm-hmm. Sensitive matter.
And what a stretched spring might actually be feeling. I mean, seriously, prepare yourselves for that one.
It's a great example.
And the connection between energy just zipping around and our own inner experiences, plus a completely fresh angle on what consciousness really boils down to. Trust us, you probably won't look at your coffee mug the same way after this.
Probably not. Okay, let's start with the fundamental head scratcher. Ready? We are walking, talking, feeling beings made of the exact same stuff as, rocks and toasters. Atoms are atoms, whether they're inside your brain or part of your garden gnome.
Yeah, it doesn't make sense on the surface. How does this seemingly inert stuff give rise to our incredibly rich inner lives?
Yeah.
It's like the ultimate magic trick.
It really is. We're made of what seems like, as you said, numb, dumb, and thoughtless matter, yet here we are thinking about thinking.
Exactly. And Pepperell really zeroes in on this kind of absurdity. These basic building blocks are just everywhere, doing the same basic particle-y things. So the big question he poses is, could it be that matter, even in its most fundamental form, has some kind of internal state, some way of, experiencing things?
And this is where he brings in Thomas Nable's famous question, what is it like to be a bat?
Ah, yeah, I know that one.
It's designed to highlight that consciousness isn't just about processing information like a computer might. It's about having a subjective, internal, what it's likeness.
A feeling.
A feeling, exactly. And Pepperell takes this idea and really runs with it. He proposes that maybe even a seemingly simple material system like an atom, or that spring, might have its own rudimentary what it is like, its own intrinsic perspective.
He's being literal here, isn't he? Not just poetic. He's seriously suggesting we should, scientifically investigate the possibility that matter feels in some very basic way.
Totally literal. Dead serious.
Which just flies in the face of the standard idea, that only super complex things like nervous systems or brains can have anything resembling mental states. It's deeply counterintuitive.
It absolutely is. But he argues it's a possibility worth taking seriously if we ever want to solve the mind-body problem.
Okay, so how? How do we even begin to approach something so out there?
So he introduces this framework called psychophysical parallelism.
Psychophysical.
Parallelism.
Think of it like looking at a coin. You can see the head side, or you can see the tail side, but it's fundamentally the same coin, right?
Right. One coin, two views. So Pepperell suggests that every system, whether it's a single particle, a spring, or your entire brain is one unified thing, but we can look at it or understand it in two deeply connected ways.
Two perspectives.
Two perspectives. First, there's the extrinsic view. That's the physical side, the stuff science is good at, what we can measure, observe, quantify with our instruments. Forces, energy, mass, charge, all that.
Okay, the outside view. Got it.
Then there's the intrinsic view. This is the tricky one. It's the system's own internal experience, its psychological state from its own perspective. We can't directly see this intrinsic side.
Because we're on the outside.
Precisely. But Pepperell argues we might be able to infer it from its physical behavior from that extrinsic view. So psychophysical parallelism, two parallel aspects, the physical and the psychological of the same underlying reality.
Okay, I think I'm getting it. Two sides of the same coin. We watch how something acts physically, its extrinsic behavior, and from that, we try to make educated guesses about what might be going on internally, intrinsically.
That's the core idea.
So what about cause and effect? In physics, forces, energy transfers, they make things happen. Does this intrinsic psychological side have its own kind of push or pull, its own causes?
Absolutely. That's a key part of the framework. From the extrinsic physical perspective, everything happens according to the known laws of physics, forces, fields, energy exchanges, cause changes.
Standard stuff.
Standard stuff. But Pepperell proposes that there are parallel psychological causes operating on the intrinsic level. He introduces concepts like conflict, which he suggests is a kind of psychological counterpart to physical force, and other ideas like will and volition, which we'll definitely need to unpack more later.
Okay, so physical force has a parallel. Conflict.
That's the proposal. The really crucial point here, though, is that this whole framework lets us scientifically investigate the connections between the physical and the psychological without first having to solve the giant metaphysical puzzle of what mind and matter ultimately are.
Ah, okay, so it sidesteps the really hard philosophical problem and says, let's just look for the parallels.
Exactly. We can look for correlations, make inferences, maybe even predictions based on this two-sided view.
This is still pretty mind-bending, I have to say, but I can sort of see how you could start to investigate it. Now, you mentioned he brings up Isaac Newton surprisingly early. Apples, gravity. What's a link to matter? Feeling.
Yeah, this is where it gets really fascinating, I think. Pepperell goes back to a really key idea in Newton's famous Principia Mathematica, the concept of vis inertia.
Inertia, like things wanting to stay put or keep moving.
Right, often just translated as inertia, that tendency of an object to resist changes in its state of motion.
Yeah.
A ball at rest wants to stay at rest. A ball rolling wants to keep rolling unless something stops it.
Classic Newton, yeah. Learned that in school.
Exactly. But it's how Newton described this that caught Pepperell's eye. Newton didn't just talk about mass and resistance. He said a body is not without difficulty put out of its state of rest or motion.
Not without difficulty. Interesting phrasing.
Very. And he used other words, too, like withstand, difficulty, persevere, strive, and even endeavor to describe how an object responds when a force tries to change its state.
Strive. Persevere. That sounds almost animate.
Doesn't it? Pepperell highlights this language and suggests it sounds an awful lot like a kind of inherent will, or perhaps even a desire, within all matter, what Newton called active matter, to maintain its current state.
So the father of classical mechanics, Mr. Rational himself, used language that hints at some kind of inner drive or agency in matter.
That's the interpretation Pepperell puts forward. He's suggesting that maybe Newton glimpsed something deeper there, an intrinsic aspect, even if subsequent science focused purely on the quantifiable extrinsic side.
Wow, that really makes you wonder, doesn't it? What if science had taken that striving aspect more seriously back then?
It's a massive what if, right?
Yeah.
Pepperell kind of muses that if this intrinsic aspect hadn't been largely sidelined in favor of purely mechanical descriptions, our whole understanding of the universe, maybe even life itself, could be radically different today.
Okay, so that historical detour is fascinating.
Yeah.
But let's connect it back to the core physics force, energy, work. How did these standard concepts fit into Pepperell's two-sided view?
Right. So Pepperell explains that Newton's insights about force and motion can be, and often are, reframed in the language of energy transfer and work.
Energy and work, okay.
Energy, basically, is the capacity to do work. And work is done when a force acts over a distance to move something against some kind of resistance, changing its energy state.
Like kicking that ball again.
Perfect example. Your foot applies a force, moves the ball over a short distance, it does work on the ball, and transfers kinetic energy, the energy of motion, to it. The ball accelerates.
Simple enough. Physics 101. But where does the feeling part come back in here?
Well, Pepperell points out something interesting. While these concepts of energy and work were first developed to understand machines, steam engines, and the like, by the 19th century, thinkers like Gustav Fechner, Helmholtz, Ernst Mach names, you might know, they started applying these same energy work ideas to living systems, even to the brain and the mind. They started viewing them as complex energy processing work-doing systems.
Ah, so seeing the brain not just as a thinking machine, but as an energy machine too.
Exactly. Now, Pepperell notes that in recent decades, the dominant metaphor for the brain has become the computer, focusing on information processing.
Right, the computational model.
Yeah. But he wants to revive and update that older energy work perspective, but crucially, integrating it with this idea of a parallel intrinsic psychological side.
Okay, bringing energy back into the mind-brain picture.
And he makes another interesting observation. Even today, you hear physicists and chemists using surprisingly, psychology-tinged language, don't you? They talk about reactions being favored, or molecules preferring a certain configuration, or particles experiencing a force, or systems wanting to reach equilibrium.
Yeah, that's true. You hear it likes to do this or it feels this force. We sort of anthropomorphize instinctively.
Right. And Pepperell asks, what if this isn't just convenient shorthand? What if it hints at an underlying reality? What if matter does have preferences in a very basic sense?
Okay, so how does he formally make that leap from energy transfer, which we can measure, to this proposed internal experience?
This is really the absolute core conjecture of his whole book. Pepperell proposes this. Every time energy is transferred to a material system, something measurable, extrinsic, there is a simultaneous parallel transfer of a fundamental psychological property that exists only from the system's own intrinsic viewpoint. And he gives this fundamental property a name: experience.
Experience with a capital E.
Capital E, yes. To distinguish it from our everyday conscious experience. So the key insight, the big leap, is proposing that any energy transfer entails a corresponding change in this basic intrinsic experience.
So energy moves from A to B physically, and experience moves in parallel, intrinsically. But we only directly perceive the energy part.
That's the idea. And he suggests this fundamental experience has certain qualities or features, like the conflict and will we mentioned earlier, those proposed psychological parallels to physical force and inertia. And just to be clear, the physical change we observe, like the ball moving, is still caused by the physical force, the energy transfer. But he's saying there's this accompanying psychological change happening intrinsically, driven by its own parallel psychological causes that he argues science hasn't really studied yet.
Okay, this is still pretty abstract, gotta say.
Yeah.
We need something more concrete. What about that stretched spring you teased us with earlier? How does that illustrate experience?
Perfect example to make it tangible. Okay, imagine an ideal spring just sitting there, totally relaxed, no forces acting on it, no work being done, no energy transfer.
Equilibrium.
Extrinsically, yes, it's in physical equilibrium. Intrinsically, Pepperell suggests it's in a state of psychological repose. Think of it as like zero conflict, zero active experience. It's just a happy, chilled out spring.
Yeah, feeling content.
Got it. Now, you come along and you grab one end and stretch it. You have to apply a force if you're doing work on the spring, right?
Yeah. Takes effort.
That effort, that work, transfers energy to the spring, which it stores as elastic potential energy. Extrinsically, we observe it's displaced from its equilibrium length. It's under tension.
Okay, physical description, now the intrinsic part.
Intrinsically, Pepperell proposes that this act of stretching creates conflict. There's a psychological tension now between its current forced, stretched state and its inherent wish or will. Remember Newton's striving to be back at its original shorter length.
So the spring doesn't like being stretched. It has an internal discomfort.
That's the inference, yeah, based on this psychophysical parallelism. And from this idea of conflict, we can even start to infer the valence of the spring's experience, whether it's positive or negative.
Like pleasant or unpleasant.
Exactly. When the spring is stretched against its will, its tendency to return to equilibrium, Pepperell suggests its intrinsic experience might have a negative valence, something analogous to displeasure, discomfort, stress.
Okay.
Conversely, when you let go and the spring snaps back, returning to equilibrium in accordance with its will, its intrinsic experience might have a positive valence, something akin to pleasure, comfort, relief.
Whoa. So stretching is bad, relaxing is good.
Yeah.
From the spring's point of view.
In this framework, yes.
Yeah.
And there's more. The intensity.
Ah, right. So if I stretch it just a tiny bit versus stretching it a whole lot.
Exactly. Pepperell suggests the intensity of this intrinsic feeling is directly related to the amount of work done, the amount of energy transferred. The more you stretch it, more energy stored, more work done against its will.
Right.
The more intense the inferred displeasure or conflict.
And presumably, the more intense the pleasure or relief when it snaps back really energetically.
Precisely. Greater energy fluctuation corresponds to more intense experience, whether positive or negative. And as he points out, while it sounds radical now, this idea of a basic psychology of matter isn't entirely new. Thinkers like Spinoza, Leibniz, Fedner back in the 19th century, they all hinted at similar ideas in different ways.
This is genuinely making me look at, well, everything differently. A bouncing ball, a vibrating guitar string. Okay, so how does this framework apply to much more complex systems like, us?
Yeah.
Our brains, our nervous systems.
Right, that's the crucial next step. Pepperell extends this fundamental concept, the link between energy fluctuations around an equilibrium state and intrinsic experience, to the building blocks of our nervous system. Neurons.
Okay, neurons firing. How does that fit?
Well, think about a neuron in its resting state. It's not doing nothing. It's actively maintaining an electrical charge difference across its cell membrane, the resting membrane potential.
Right, it's polarized.
Exactly. It's holding this electrical tension. Pepperell draws a parallel here to our stretched spring. The neuron is holding potential energy. It's in a state of tension, sort of poised, ready to fire.
Okay, so the resting state is like a pre-stretched spring, in a way.
You could think of it like that, yeah. It's maintaining a state away from a simple electrical neutrality. Now, what happens when it fires? The action potential.
That's the electrical signal, the spike that travels down the axon.
Correct. And what is that spike physically? It's a very rapid change in the voltage across the membrane, a sudden shift away from the resting potential, and then a very quick return back towards it, maybe even overshooting slightly before settling again.
A fluctuation.
A rapid fluctuation away from and back towards its equilibrium or resting state. So applying the same logic as the spring.
So Pepperell proposes the neuron might feel something like displeasure or conflict when it's jolted away from its resting potential during the spike.
And then maybe a corresponding feeling of pleasure or relief as it snaps back, as it repolarizes and returns to its preferred state.
Wow. So every single nerve impulse could involve this tiny, fleeting pulse of negative and then positive experience at the neuron level.
That's the conjecture. It suggests a constant, incredibly complex, microscopic dance of these rudimentary feelings happening throughout our nervous system, millisecond by millisecond, as billions of neurons fire and reset.
That's staggering to think about. And does he connect this to our overall feelings like happiness or sadness?
He suggests a possible link through intensity. The overall intensity of our conscious feelings, how strongly happy or sad or scared we feel, might be related to the total amount of energy flowing, the sheer volume of this electrochemical activity happening in the relevant neural networks at that time.
So more energy flow in brain circuits associated with fear might correlate with more intense feelings of fear.
Potentially, yes. And he even speculates that this offers a potential avenue for empirical testing. Could variations in the reported intensity of pleasant or unpleasant experiences correlate with measurable changes in energy metabolism or overall electrical activity, like voltage fluctuations measured by EEG or MEG in specific brain regions, perhaps observed using brain imaging techniques?
So you could, in theory, try to map the intensity of experience to the intensity of brain energy use.
It's a direction for research, he proposes, yes. A way to bridge the subjective report with objective measurement, guided by this energy experience principle.
This is really connecting physics, biology, and our subjective lives in a way I've never quite encountered before. But, okay, Pepperell is very careful, you said, to distinguish between this general fundamental experience that maybe all matter has.
Yes, capital E experience.
And conscious experience, the kind we typically mean when we talk about awareness. What's the crucial difference there?
This is a really, really important distinction in his framework. He argues that while all matter, down to the simplest particle perhaps, might possess this fundamental property of experience linked to energy exchange, consciousness, that rich, subjective, unified awareness that we have, is something different. It's a special, emergent property of certain highly organized, complex, and actively behaving systems, like brains.
So just because my neurons are having their little micro experiences doesn't automatically mean I am consciously aware of each one.
Exactly. Your conscious awareness isn't simply the sum total of all the tiny experiences happening in your brain. It's something more, something that arises from the way those experiences are organized and integrated.
He mentions studies on people in, like, minimally conscious states or vegetative states. How do they support this distinction?
Right. Those studies are fascinating. They show, for instance, that sometimes individuals who appear completely unresponsive externally can still show brain activity, indicating they understand instructions or are processing language.
So complex activities happening.
That complex neural activity, energy flow, presumably lots of individual neuron experiences are happening. But it doesn't necessarily translate into full-blown conscious awareness or the ability to report it. It suggests that complex brain activity is necessary for consciousness, but it's not sufficient. It's not simply equivalent to it. Something else is needed.
Okay, so if basic experience is tied to energy transfer, what's the extra ingredient that elevates some of that experience to the level of consciousness?
Pepperell suggests it comes down to complexity and integration. Consciousness, he hypothesizes, emerges when the patterns of energy flow and the associated experiences within the brain reach a critical threshold of complexity.
Complexity meaning?
Characterized by two key features working together. First, a high degree of differentiation, meaning lots of different brain regions are doing their own specialized processing, generating diverse patterns of experience. And second, a high degree of integration, meaning these diverse regions are highly interconnected and are communicating and influencing each other rapidly, working together in a coordinated way.
Differentiation and integration. He used a music analogy for this, didn't he?
Yes, it's a great analogy. Think of the non-conscious, localized experiences happening in separate, uncoordinated brain regions as just individual scattered musical notes or sounds, maybe little blips of conflict or relief here and there.
Okay, just noise.
Kind of. But when the brain reaches a sufficient level of complex, integrated activity, when these different regions start firing in synchrony, influencing each other, creating large-scale resonant patterns, it's like those scattered notes suddenly come together. They form a unified, rich, dynamic, and coherent. Well, he calls it a melody of mind.
The melody of mind. I like that.
It's evocative, isn't it? And it's during this period of highly differentiated and integrated activity, this complex melody, that Pepperell suggests there is truly something it is like for the system as a whole, or at least for the integrated parts of it, to experience these diverse states simultaneously and persistently. That's when consciousness emerges.
That makes a lot of intuitive sense. Consciousness isn't just more basic experience. It's a specific kind of highly organized, integrated pattern of experience.
Precisely. And he notes that this general idea, consciousness arising from complex integrated brain activity, actually aligns quite well with some prominent neurobiological theories of consciousness that are already out there, like integrated information theory, for example.
Even if those theories don't necessarily include his fundamental idea about all matter having experience.
Right. They focus on the structure and dynamics of the information processing or the energy flow, but Pepperell adds this underlying layer, suggesting what is being integrated might be these fundamental units of experience. He also briefly touches on the role of self-referential loops in brain activity.
Like feedback loops.
Yeah, kind of like pointing a video camera at the screen showing its own feed. He suggests these kinds of recursive, self-monitoring processes in the brain might be crucial for the emergence of self-conscious experience, our awareness of being aware.
This is painting an absolutely incredible, multi-layered picture, from basic physics up to self-awareness. Now, the book apparently gets more technical in part 2. Can you give us a sense of the details he dives into there without getting us totally lost?
Sure. Part 2 is where he tries to, let's say, nail things down a bit more formally. He provides definitions for the key concepts we've been discussing, proposes some fundamental principles or laws, suggests ways to quantify things, and outlines potential experimental methods. But he's very clear these are provisional definitions and ideas meant to kickstart research, not the final word.
Okay, so just give us a quick flavor of some of these new terms he introduces to describe the intrinsic side.
All right, well, we've got system, extrinsic perspective, intrinsic perspective. We mentioned repose. That's the psychological parallel of physical equilibrium, the baseline state of minimal experience. Then there's conflict, the proposed parallel to force, and will, linked to inertia, or the tendency to maintain a state. He even adds nolition, which is like the resistance to change, the intrinsic aspect of inertia.
Conflict, will, nolition.
Then he proposes a potential unit for quantifying experience itself. He calls it an EMP. Again, very speculative. He talks about negative experience or distress, perhaps measured in units called algons, from the Greek word for pain.
Algons.
And positive experience or relief, measured in hedons, from the Greek for pleasure. He even coins terms for the rate of change of these feelings, like a sudden onset of distress might be shock, and a sudden onset of relief might be joy. And the overall strength or magnitude of any experience is its intensity, measured in cratons.
Wow, okay, EMP. Algon, hedon, kraton. He's really building a whole potential vocabulary for the psychology of matter. It sounds almost like thermodynamics, but for feelings.
That's a great analogy. In fact, he explicitly proposes laws of experience that are meant to run parallel to Newton's laws of motion and laws of psychodynamics that parallel the laws of thermodynamics.
Seriously, like a first law of psychodynamics.
Yes. His first law of experience, for instance, suggests the conservation of experience within a closed interacting system. And a fundamental law of psychodynamics is the tendency of systems to spontaneously move towards states of lower conflict, towards repose, much like physical systems tend towards lower energy states or higher entropy.
Fascinating. And how does he imagine we could actually test any of this experimentally? Especially for something simple like that spring.
For simple systems like a spring mass oscillator, he suggests carefully measuring the physical energy input, work done stretching it, the energy dissipation, like heat due to friction, and the energy output, kinetic energy as it moves. The idea would be to see if you can model the system's behavior more accurately, or perhaps find anomalies that could be explained by assuming these parallel intrinsic states and their tendency towards repose.
So looking for subtle physical effects that hint at an underlying psychological driver.
Kind of. For more complex systems like biological ones, his main guiding principle is quite evocative. Follow the energy and the experience will follow.
Follow the energy.
Yeah. By meticulously tracking where energy flows, where it's stored, where work is being done within a complex system, he believes we can start to map out the corresponding intrinsic landscape of conflict, relief, distress, and repose, and see if that map helps us understand the system's behavior, its self-organization, maybe even its evolution.
This is incredibly ambitious, isn't it? Trying to bring the subjective, the intrinsic, into the realm of quantitative science.
Hugely ambitious, but arguably necessary if we want a complete picture.
Okay, so after laying out the theory and the technical framework, in part 3, Pepperell looks back through history, finding thinkers who sort of touched upon these ideas, maybe without realizing the full implications. Let's dig into some of those historical echoes of what matter feels. He starts with Leibniz and his famous mill argument, right?
That's right. Gottfried Wilhelm Leibniz, the 17th, 18th century philosopher and mathematician, he used this thought experiment. Imagine a machine, complex like a mill, that was built to think and perceive if you blew it up to a huge size so you could walk inside it.
Like in that movie, Honey, I Shrunk the Kids.
Huh, yeah, kind of like that. Leibniz argued all you would see are parts pushing against each other, cogs, livers, fluids. You'd never see perception itself or thought. He used this to argue against purely mechanical explanations of the mind.
Okay, so how does Pepperell reinterpret Leibniz's mill?
Using his psychophysical parallelism lens, Pepperell says, well, Leibniz is right about the extrinsic view you'd only see physical parts interacting. But Pepperell argues that the mill, as a physical system undergoing work and energy transfer, would also have parallel intrinsic psychological states. Maybe not conscious thought, but perhaps non-conscious drives, moments of conflict as parts engage, relief as they disengage, corresponding to its physical operations.
So even the giant machine isn't just dead matter. It has a kind of proto-feeling, an intrinsic side tied to its mechanics.
That's the implication from Pepperell's view. He also suggests that Leibniz's concern about how individual perceptions could combine into a unified consciousness, what Leibniz called the problem of the unity of the multitude, could potentially be addressed by his framework's focus on functional integration. When those basic experiences become highly integrated, perhaps unity emerges.
Interesting spin on a classic argument. Next up, he discusses Émilie du Châtelet. She's a fascinating figure, but maybe less well-known. What was her contribution regarding leaving force?
Yes, du Châtelet was an amazing French philosopher and physicist in the 18th century, a key figure in the transition from Newton's ideas to modern physics. She was deeply involved in the heated debate about vis viva, which literally means living force.
Living force, what was that?
It was an early concept related to kinetic energy, basically. There was a big argument about whether the force of a moving object was proportional to its velocity, mv, like momentum, or the square of its velocity, mv. Du Châtelet, through experiments and reasoning and translating Newton's Principia into French with extensive commentary, played a crucial role in establishing that mv, the basis of kinetic energy, was the correct measure of this living force.
Okay, so she helped define energy. How does Pepperell connect her work to what matter feels?
He revisits the classic falling apple example through her lens. Extrinsically, we see gravitational potential energy converting into kinetic energy, related to du Châtelet's vis viva. But Pepperell asks us to also consider the intrinsic perspective. What about the transfer of experience within the interacting apple-Earth system as this energy transformation happens? He speculates that maybe considering these parallel psychological causes, like the system striving towards a state of repose, apple on the ground, might actually offer simpler or more general explanations for why things happen the way they do, perhaps even more fundamental than the purely physical laws.
So the why might be partly psychological, even for an apple falling.
That's the provocative suggestion.
Okay, moving on to Michael Faraday. Electricity, magnetism, invisible fields of force. How do these intangible concepts fit in?
Faraday's work in the 19th century was revolutionary because he moved beyond thinking just about particles interacting directly. He introduced the concept of fields, invisible influences extending through space, like magnetic fields or electric fields, which he visualized using lines of force.
Right, fields permeate space.
Pepperell extends his psychophysical parallelism framework to these fields themselves. He suggests that a field isn't just a mathematical description of potential forces. Perhaps it also represents a potential for intrinsic experience. So when a test particle, like an electron, enters an electric field,
it feels the force.
Extrinsically, yes, it experiences a force and accelerates. Intrinsically, Pepperell proposes, it simultaneously feels and experiences an interaction with the field that has a certain quality, intensity, maybe even valence corresponding to the energy being transferred to it by the field. This broadens the scope of his theory dramatically, suggesting even the seemingly empty space filled with fields might have an intrinsic experiential potential.
Mind blown again. Okay, what about Ernst Mach? You mentioned him earlier regarding the energy view of the mind.
Yes, Ernst Mach, the late 19th, early 20th century physicist and philosopher. He had a very radical view, often called neutral monism. He argued there's no fundamental distinction between mind and matter, the physical and the psychical.
No distinction at all.
He believed they were just different ways of organizing the same fundamental elements, which he thought were sensations. For Mach, physics, physiology, psychology, they were all just studying the same basic thing, the connections between sensations or phenomena. He was a strong proponent of psychophysical parallelism.
So he really embraced the two sides of the same coin idea.
Absolutely. And crucially, he explicitly stated his belief that sensitivity is a general attribute of matter. Pepperell sees Mach as a really important forerunner to his own framework, someone who wasn't afraid to challenge the deep division between the objective and subjective realms.
Okay, nearly there on the historical tour. He brings in Erwin Schrödinger, the physicist, famous for his cat, but also for his thoughts on life. What about negentropy?
Right. Schrödinger, in his famous little book, What is Life?, introduced the concept of negentropy, or negative entropy. He argued that the defining characteristic of living systems is their ability to maintain order and complexity, to resist the universal tendency towards decay and disorder, entropy. They do this, he said, by constantly feeding on negentropy from their environment, essentially sucking in orderliness, or free energy.
So life is like an island of order in a sea of chaos.
That's the idea. Now, how does Pepperell interpret this? From the intrinsic perspective, he suggests this biological drive to maintain order and structure, to suck in negentropy, can be understood as a fundamental striving to minimize intrinsic distress associated with disorder and decay, and maximize intrinsic relief associated with maintaining a stable, organized state closer to repose.
So the drive for life and order is intrinsically felt as a drive away from discomfort and towards comfort.
That's the proposed parallel. He connects this to the dynamic self-organization we see in living things and even in some non-living phenomena like cymatics, patterns formed by sound vibrations, suggesting it's all driven by this fundamental tendency of matter-energy systems to seek states of minimal intrinsic conflict or distress.
Fascinating link between physics, life, and feeling. And finally, Rudolf Arnheim and aesthetics. How does art fit into this?
Rudolf Arnheim was a psychologist who applied Gestalt principles to the study of art and visual perception in his book Entropy and Art. He argued that our perception of order, balance, and beauty in a work of art isn't just subjective fancy. It actually corresponds to the physical forces and tensions present in the artwork's form, reaching a state of optimal balance or lowest tension.
And so a balanced composition feels good because the underlying forces are resolved.
Exactly. Arnheim believed that perceiving such well-ordered forms creates a corresponding state of reduced tension in the observer's nervous system, which is experienced intrinsically as pleasurable. Pepperell connects this directly to his framework. The physical reduction of competing forces, extrinsic, leads to a pleasurable intrinsic experience, relief, repose. He even uses examples like paper marbling, where chaotic, swirling inks spontaneously settle into ordered patterns, as a visual metaphor for these psychophysical principles at work, the interplay between order and disorder, tension and resolution, distress and relief.
So from a falling apple and a stretched spring, through energy fields and living cells, all the way to our appreciation of beauty and art, Pepperell weaves this incredible tapestry, suggesting that this intrinsic feeling aspect might be a fundamental, universal, and deeply overlooked feature of reality.
Absolutely. These historical perspectives aren't just interesting anecdotes. They serve to show that the core intuition behind what matter feels, the idea of a more interconnected, perhaps even subtly ensouled universe, has actually been simmering beneath the surface of scientific and philosophical thought for centuries. Pepperell's work is a bold attempt to bring these long-standing intuitions into a cohesive, modern, and potentially testable scientific framework.
Wow. Okay, this has been an absolutely mind-blowing deep dive, truly. So just to try and recap the essence, Pepperell is putting forward this, well, revolutionary idea that matter itself, down to its basic constituents, can feel.
Yeah.
That it possesses an intrinsic psychological perspective, this capital E experience, that runs in parallel with its observable physical properties.
That's the core proposal, yes.
And we've journeyed through some pretty wild concepts flowing from that. Sensitive matter, the potential inner life of a simple spring, the fundamental link between energy transfer and this intrinsic experience, and then building up to a new perspective on consciousness itself, not as something totally separate, but as a highly complex, integrated organization of these fundamental experiences.
Exactly right. And it's so crucial to keep in mind, as Pepperell himself emphasizes, that this is a working document. It's a proposal, a framework designed to provoke thought, to spark discussion, and most importantly, to stimulate new lines of experimental research. He's not claiming to have all the answers. He's suggesting a new way to ask the questions.
Offering a toolkit, like you said at the start, with many potentially testable hypotheses baked in. The real adventure, I guess, lies in seeing if and how those investigations might pan out in the future.
Precisely. It's the beginning of a research program, potentially.
Okay, so as we wrap up this incredible journey today, let's leave you, our listeners, with a final thought to really chew on. If we seriously entertain this possibility that even the simplest bits of matter around us have some form of intrinsic experience, however rudimentary, however different from our own, how does that fundamentally change your perspective on the universe, on the nature of life, on your own connection to the physical world, and your place within this vast, maybe surprisingly sensitive cosmos?
It really does challenge some of our deepest assumptions about the division between mind and matter, observer and observed.
It definitely makes you think twice about, well, everything. Kicking a stone, bending a paperclip, maybe even the atoms in the air we breathe.
Indeed. It invites us to reconsider the very fabric of reality and the profound, perhaps inseparable entanglement of the physical and the psychological.
And on that deeply philosophical, maybe even slightly unsettling note, we conclude this deep dive. Thanks for joining us on this exploration. Until next time, keep questioning, keep wondering.
And keep diving deep.